In this video, we're going to answer a really interesting question, which is which way round should we present V equals IR? And what I mean by that is, should we tell students that it's V equals IR? Should we tell them that V over I equals R? Or should we tell them that I equals V over R? And there's really interesting ways why we might pick any one of these. So before we answer this exact question, I'm just going to talk about a more general point, which is the same question for this formula. Which way round should we present speed as distance over time? Should we present it this way? Should we present it this way? Or should we present it this way? Now, in general, what you should do is you should ask yourself this question. You should say, which quantities in the formula can I measure directly, and which quantities arise because of the other two? So if you're not sure what I mean by that, one really good question to ask yourself and ask students is actually, right, in this formula here, which bits here can you physically go and get me? So what have we got? We've got speed, we've got distance, and we've got time. So which one of these can you go to the prep room? Can you go and ask the technician for? Well, you can go to the prep room and you can go and get a distance, right? You can go and get a meter ruler and measure a distance. You can also go and get a stopwatch and you can measure a time. What can't you go and get? You can't go and get a speed. Right, you can't say, oh, dear Mr. and Mrs. Technician, can you please give me a speed? But what can you do? You can create a speed by changing the distance or the time. So we can directly measure distance and time with a meter or a stopwatch, and we can create a speed which we can then calculate based on these two. So this answers our question. This is probably the best way of presenting a formula, because we are creating a speed from these other two things which we can go and get. And for our understanding, this is the best way to present things. So this then links to other ideas as well, such as if we're graphing things, distance and time, what are we doing here? The gradient here equals the speed. So we're working out or calculating the speed based on the other two. And we can really approach that for all other equations. What are we creating? What can we actually directly go and get? So let's look at this question here. Right, of these three quantities here, we've got potential difference, we've got resistance, and we've got current. Which one of these can we get? Well, we can go and get ourselves a potential difference from the prep room. We get a battery that has a positive and negative terminal, and you plug that in a circuit and the charges will flow round in the circuit. We can go and get a resistance. We can go and get a piece of metal with a low resistance, or we can go and get a piece of plastic, for example, with a high resistance. And then we have to ask ourselves, can we get a current? Can I get a flow of charges? Can you just give me a flow of charges? And you can't. But you can create a flow of charges by putting a battery in a circuit. We put a battery next to a resistance, even if it's a low resistance, and we create this flow of charges. So we should maybe then think about presenting it this way round. So for our understanding of the relationship between the two of them, this is a really good way to present it. Right, we create the current from a potential difference in a resistance. But This is a weird form. This is kind of an exception, I would say, and that there are advantages to presenting the other two ways round. So when we come to calculate resistance, resistance is defined as potential difference divided by current. So actually, in this case, we might want to present it in this way round. And this is always true. Resistance is purely the ratio of how much energy you need per charge to how much the charges actually move. Now, finally, there's this relationship here, which is how we usually present it. And actually, there is a benefit to this. This is probably the easiest way for students to remember it. It just kind of flows off the tongue, V equals IR, and it's how it's often presented. So there is a benefit to it. But you have to, I think, be really clear in your understanding and your explanation to students that there are benefits and reasons to all of this. And also realize that if there's any other formula, we generally want to present it in this way round here. So just to give a couple of very quick examples, density is mass over volume, follows the same pattern. Power, energy over time, sort of follows the same pattern. Energy, MGH, sort of follows the same pattern. Now, it's obviously not quite as simple as I'm making out. For example, why does this appear in different places? But, the general principle remains true. If you kind of think about it more deeply in the context of each formula.